A very good afternoon, and thank you for joining us on this webinar on scientific landfill closure practices. This is a part of our webinar series aimed at capacity building and solid waste management under the CCAC, or the Climate and Clean Air Initiative. The Climate and Clean Air Initiative was launched by the UNEP and aims to capitalize rapid reductions in short-lived climate pollutants to protect human health, agriculture, and environment. We have with us today Professor Brajesh Dubey from IIT Kharagpur. He brings with him 16 years of rich research, teaching, training, and industrial outreach experience in the areas of solid and hazardous waste management. He's been teaching courses in the areas of solid and hazardous waste management for nearly a decade. He has also authored more than 200 publications in his area and taught in several universities in USA, Canada, New Zealand, China, and India. So we will start with a 45-minute presentation from Professor Dubey and then open for a question and answer session. You can send in your questions during the session or post the presentation using the small chat box on the right-hand side of the page. With that, I'm going to enable the audio for our expert for the day and turn things over to Professor Brajesh Dubey.
Yeah, good afternoon, everyone. Thank you, Kaushik, for the introduction. So as Kaushik mentioned, today we'll be talking about scientific landfill closure practices. And so we'll get started with that. And so just some of you, I was looking at the attendee list, and I found some familiar faces there as well. So who has taken that online course on solid waste management last semester, or just which happened last month, and just in October. So again, welcome back. So for those of people, you may have seen some of these slides already, but again, it will be a good revision. So what we are trying to do here is to, as we know, in a developing country contest, and as well as for the developed countries, landfill is there. Landfill is whether we like it or we don't like it. Landfill is being used as one of the way of, I would say, disposing waste in many countries around the world. If you just don't take into account few countries in the Western Europe, which still uses landfill, but at a very minimal level. But other than that, most of the countries, including North America, most of Eastern Europe, some countries in Western Europe, including UK, most of Asia, Africa. So we are relying on landfill for the most part in managing our garbage. And when we talk about in the Indian context, we are actually working with dump sites most of all. So today what we will talk about, we'll touch upon a little bit on dump site, but we'll also have, just to get things started, we'll have just a quick overview of the waste generation and characterization, since I was not that much sure of what kind of audience there will be. So I thought just give you a quick, a few slides overview of what kind of waste we generate and how we are managing it in the country right now. Then we'll go straight to the landfill. So we'll not talk about the other aspect because the topic is on closure of the landfill, what are the ways to close it. And when we do the landfill closures, we have to do some landfill cap, we have to talk about the stormwater control, we have to talk about long-term management of leachate and gas, so we'll do that. And as you know, if you have taken any solid waste, if you've read about solid waste management, landfill, the day it stops accepting garbage, from that day, that's called the landfill being closed for taking any further garbage in. From that day, as per the regulation requirement, we have to still monitor the landfill performance over usually around 30 some years. Some regulation requires less, some regulations requires more. But say if you think about 1.5 decade to 2 decade to 3 decades, so that requires money. So there has to be certain financial plan, financial assurance. We'll talk about a little bit on that. And then once the landfill is matured, when we say matured, the leachate production has gone down, not much gas production coming in, waste has degraded for most part, we don't see much settlement happening. Can we do something with that landfill? What are the uses for the old landfill? And then we'll get into the concept of landfill mining, and we'll end our presentation there. So to just a quick overview in terms of the waste generation and characterization in India. India is still, if you look at the per capita waste generation per person per day, at an average throughout India, We'd say around zero point 0.6 to zero point 0.7 kg per person per day. This data is a slightly older data, the published in 2015, but the data came out a few years before that. And here we, as you can see, for most part, we are looking at around 0.5 being the average. The CPHEO manual, if you have looked at that manual, that requires you to take around 0.6 kg per person per day for some design calculation. So even if you go by the CPHE manual 0.6, but that's an average value for India, especially for the urban India. But if you are in, even within, say, right now, Delhi is in the news for air pollution problem. We may touch on that later today. But if you think about just in Delhi city, if you are in like a wealthy area of the city, you may find waste generation to be much higher. So if you're in South Extension, Defense Colony, Greater Kailash, or like a Vasant Vihar, those areas you may find per person rate to be higher compared to if you go to some of the other areas of Delhi, which is not that well off, where you see mostly low middle class or middle class families. So there is a there will be variability, but in general, we can take around 0.6 to 0.7 kg per person per day. So that's the typical waste that is being produced. That's the total waste that is coming in. And different cities, this was a study again, so the study done by municipal manual. Manual is presenting these tables. So depending on the population of the different cities or towns we are looking at, the waste composition keeps on changing to some extent. For most part, the important stuff is the compostable material, which is can be composted or can be anaerobic digested. That we see has a variability of around 30% to 56%. So as you go into the bigger cities, which population of more than 5 million, you see that the compostable matter actually goes down because we start seeing more and more packaging material is started showing up, all those plastics and those which is not really compostable. And as we go to the lower, like smaller towns and semi-urban areas, we start seeing more compostable material. And there is some, of course, some variabilities there in between. And the inert material, which inert material for most part is finding its place in the dump site today in India and in the landfill in many parts of the world. So that's also substantial. Like nearly 40 to 50% of the waste is going to the inert material. So that's on in terms of composition. And then if you look at the chemical characteristics, again these are not very exhaustive survey, as you can see from the second table. The second column in both the tables. You see that it's mostly a few cities compared to the size of the India. The data is not that substantial, but it does give a good idea of where we are. And we do see some of this carbon nitrogen ratio pretty good, around 25. So it could be a good compostable material, or even anaerobic digestion could be done for some of these stuff. Calorific value, although we are trying to go for a lot of waste to energy plant, even the recent Niti Aayog, the 3-year plan that they came out with, I think they call it some paper, which is there on their website. That also kind of is suggesting that we should go more and more into waste to energy plant. But as you can look into calorific value, it's pretty low. Typical, if you don't have less than anything less than 2,000, that's kilocalories per kg. It's very difficult to have a stable working waste to energy plant. We can achieve that if we do some source segregation. Unfortunately, we don't do that. We have to do it as per the new MSW management rules, but we are not able to do that. So that's why we are where we are in terms of just a snapshot. And this is the same thing being presented in a pictorial way, where you can see that fruits and vegetables and food waste, that's predominantly the compostable organic matter. When we talk about recycle, the paper, plastic, glass, and metals, and most of these material are being taken away by the commodity owners. So they don't really show up in the dump site, the good quality ones. The ones which cannot be recycled, that will only show up in the dump site. And some of the soiled material, which is mixed with other material together, may show up. There are some toxic substances present. This particular pie chart is not to scale. Don't think that 25% is toxic substances. This is just to show you what are the different types of like the things are present in a municipal solid waste. Then you may have some soil waste like bulk and cotton, sanitary napkin, disposable syringes. So those things also, it's like a household hazardous, part of it is household hazardous waste. So as if you have looked into MSW Management Rules 2016, we should do a three-way collection. One is for the dry waste, one is the wet waste, and third one is the household hazardous waste. Some of the material from the toxic substances as well as from here should make way to household hazardous. Some of these are also could be classified as biomedical, but we don't have a house-to-house biomedical waste collection, so we can put it in household hazardous waste. So in terms of percentage-wise, if you look at organic fraction is still pretty high, 40 to 60% is the organic fraction of municipal solid waste. And here paper, which again is organic, but this paper is something which is not very hard to degrade. So high lignin content, that's around 3 to 6%. Inert material, 30 to 40%, some plastic metals. And these are actually, it looks like this is the sample after the commodity wallas. It's not the waste that is being produced at the house, but it's waste what is being disposed, which is coming out of the house because recyclable plastic papers and glass is taken away at the house level itself. So in terms of collection, treatment, and disposal, there are a variety of sources from the waste comes in. It goes to household, then it is a primary collection, secondary collection, goes to transfer station, and then it goes to dumping sites for most part in Indian context. Some composting is being done. Then in terms of recycling, we have household and buyers are there. Then rack pickers from primary collection. There are recycling dealers and rack picking happening in the transfer station. Even at the dump sites, if you go to Balaswat or Gajipur landfills in Delhi or any big city landfill you go to, you find several people trying to take out some of these recyclable materials from there and they try to make a living out of that. So people are doing dump site picking as well. And they do help in terms of recycling, but again, the quality in terms of the environmental health and safety, as well as the processes that they use may not be much so good. So if you look at in terms of what is happening in terms of the management practice, some biochemical conversion, some anaerobic digestion happening, but very less. Composting is more happening in the country. We are trying to build some incineration plant. There are few already running in the country, but majority, nearly 90% of the waste even today is going to the landfill, which is a mostly dump site. So so we'll start focusing. As in that same thing shows up in two studies done where this was in landfilling is nearly more than 90% and around 67% was composting. This is Ranjit Enupu's paper out of 2012. CPCB, they did work for the Kerala. Again, you see landfilling is kind of a major way of disposal of garbage. So landfill, why it is still being used that much? It's a least cost option. If you don't require skilled manpower, some places you can use to convert the marshy land to the useful area, but there is a danger of contaminating the groundwater, contaminating the subsurface. Natural resources are returning back to the soil, and they could be recycled, but that's what people make an argument, but I don't know how much that is true. Gas produced can be used as an energy source, can be used for power generation, but there is a lot of problems with the landfill as well in terms of the surface runoff during rainfall that causes pollution. Even when the landfill is working, landfill is active, we do have the problem of surface runoff. And the same thing when the landfill is closed, we have to make sure that the surface runoff doesn't get inside the landfill, because that will be actually converting all those runoff to leachate. Then soil and groundwater may get polluted by the leachate as well. Because of landfill is a huge area, even a very good landfill site, you have a gas collection efficiency of something around 55 to 60%. If you find some landfill which has around 60 to 65% gas collection efficiency, that's considered a very good gas collection system. So think about 65%, even at the best. So another 35% of those are fugitive emissions. They are just getting into the atmosphere and causing those greenhouse gases and climate change and all that. So that's why we need to have a good gas collection system as part of the landfill closure and to monitor that gas collection system as well. A lot of areas required, and then you have to bring all the garbage to this location, so there is a significant transportation cost. Then if there is a buildup of methane, it may catch fire. It will probably not explode, but it will essentially catch fire. It may explode if it goes into the flammability range, but that would be very rare. But does catch fire from time to time. That happens even just last year. The landfill in Mumbai was on fire for several days. Sometimes in these dump sites, we also put things on torch. We just put the fire on purpose. When I say we, that like the people working there, the municipal who wants to just to put more garbage on top. So it's because the landfill is filling up. They need to make some space. On the middle of the night, somebody puts a torch there and it burns and then makes some space there, which is not allowed, but it does happen. So in terms of since the landfill is the focus of this webinar, so landfill closure. So let's look at what is the landfill. Some of I assume that you may have some idea, but I thought let's give you a quick layout of what a landfill is all about. So we have, so as you can see, this is the black thing is your liner system. That's your liner, and you can think of this landfill as a huge polythene bag where the garbage is in the middle here in the green portion. So that's where our garbage is. So, and we'll be talking more into the final cover today and the leachate collection and the gas collection. So, but then you have this leachate collection system at the bottom because leachate will be produced. There will be rainwater coming in. And while the landfill is accepting garbage, the rainwater will get into the landfill. So we can, the leachate will be produced, which will be collected through these pipes. When the garbage has some moisture content, so there will be leachate production through that as well, because contribution coming from there. And when the waste degrades, if you looked at the waste degradation formula, it also produces leachate. So that is also there. So we have leachate produced as a part of the waste degradation. So that's a byproduct. So that is also used on there. So in terms of we have it's in terms of the landfill, we need to have a gas collection system. We need to have a leachate collection system. So that's the leachate collection system right there. The gas collection system. It's just an example is shown that we can have a pipe, perforated pipe, and then we can apply some vacuum and collect the gas. We have to make sure that liner system is intact. So you the clay at the bottom. Surface water collection ditch has to be there, so the surface water is taken care of, and we'll spend some more time on that. So this is typically what a landfill look like. So where the landfill is selected, I will not spend too much time on this aspect. Some of these slides were sent to you up front, so you may want to use it as a reference later on. But sanitary landfill, and it's basically, we have to design it for a period of around 20 to 25 years. So, and then we do it in what is known as landfill sales. Sales means you don't, say if you had 10 acres of area to build a landfill, you don't build landfill of the 10 acres on day one. You go make for maybe a couple of acres, 2 to 3 acres. That's called cell. That could be your cell 1. Then you go to cell 2. Then you go to cell 3. So that's where you in a phased manner, so that you can use the space more wisely. So. And as part of the design and the plan, you need to have a detailed design, proper documentation, closure plan, and we'll talk about the closure plan. And it's part of the town planning. So in site selection, there has to be some buffer zone, no development there. There has to be some temporary storage facilities. So all these things are there in solid waste management rules, and also in municipal solid waste manual, which is developed. You can download that if you go on Swachh Bharat Mission, that particular urban website, or even just type a CPHEO manual for municipal solid waste management in India, and you will find that manual PDF, and you can download that. It's a several hundred pages document, but it's a nice document, good summary. So, and there are some other, these are also available there. The landfill should be 100 meters away from river, 200 meters away from pond, and all that. So this is what the landfill is all about. So let's focus on the final cover, which is the focus here. So modern landfills, they are complex engineering. So they are not like a dump sites where you have a hole, you start putting garbage in them, and then you put some dirt on top. That's not how modern landfills are managed. Modern landfills will need to have a leachate collection system. Also, you see the groundwater at the bottom. The groundwater monitoring wells has to be there. Gas monitoring probe has to be there. Rainwater retention pond has to be there. So whatever is the rainwater through the slope can go in this particular area. So here again, the groundwater monitoring. So there has to be a leachate collection system. There has to be a gas collection system, which you see over there. The storm control berm is there. So it's and then you have a very good cover design for this landfill. So in terms of the landfill closure, when we say the landfill it stops accepting waste, it needs to be closed. And when we say it needs to be closed, there is a certain regulation for that. And regulation requires us to put an engineered cap on that. So when we say engineered cap, the goal of the engineered cap is to keep the rainwater out and gas in. Because see, right now what our focus is, why this landfill, and again how this landfill became important as part of the waste management system. Since in say I would say late 70s, early 80s, we were wrestling with the environmental professionals in the Western world were wrestling with how to manage this garbage so that to minimize the environmental and human health impact. Since the technology was not as advanced as what it is today, there were not many things which can be recycled today. For example, food waste to energy was not even envisioned during that particular time. So people thought that okay, if we come up with this landfill, which will have a liner at the bottom, a cap on the top, and it will produce leachate. So I will collect the leachate. I don't want to have the leachate being built up because that will create a problem in terms of the hydraulic stability of the landfill. There will be pressure, pressure build-up that will lead to landslide. Core water pressure will to CN5 value. The geotechnical properties of the waste will get compromised, and we may have a landslide, as what has happened during this particular rainy season. We had an incident in Delhi itself, like Gazipur landfill, which had a landslide, and Ahmedabad it happened as well during the big week event that happened there during the monsoon time. So those things do happen, and to have say if you don't have a leachate collection system, that will happen more frequently because the water will build up, and then water will it will basically make the things fluid, and things will slide down. Because the CN5 values from the geotechnical class, as you know, will get compromised. So to keep them, so we have to have a leachate collection system. We need to, and when the waste degrades, it produces gas. If you just leave it outside, the gas creates problem. We started realizing that the methane gas is a problem in terms of the greenhouse gas. It's leading to the climate change, global warming, and whatever you want to call that. So we said, okay, if we can put a control, so if we have this top cover and the side cover and the side liner and the top cover, so we can control, we can collect the gas, we can collect the leachate, and will prevent the environmental harm. And at the same time, we can monitor. So we will have this groundwater monitoring system. We'll have this stormwater monitoring system. We'll have whether the landfill gas is migrating below the surface. So all those things systems can be put in place. So if you think about the landfill, is a unique kind of a structure. Even in some of the presentations I've heard, some people calling it a civil engineering marvel. It's one of the marvel of civil engineering design. Now, although people may say that landfill is more like a band-aid solution, but since no other option is available, so for example, what is happening in India today, mostly dump sites, no control, and having impact on all sorts of things, on air, water, soil. So rather than having an engineered land, I would rather have an engineered landfill than those dump sites. So it's at least a step further. And since the economics works for landfill, that's why it gets popular as well. So when the landfill is working, we have to, since the post-closure care period, 30 years is what is required for the most of the Western regulation. Some places even 15 years. So what I saw was 15 years has been allowed that you can use it for 15. You can do the post-closure care period for 15 years, especially if you have mostly inerts going to the landfill. So even in the MLW management rules, it says that since we do the wet and dry separation and everything needs to be treated first, if only the inerts can go to the landfill. So if only inerts go to the landfill, we can have this post-closure period for 15 years. But again, I don't think the post-closure care period will end just when 15 years is over. Say, for example, if a engineered landfill, it stops collecting garbage on 31st December 2020. It's not that on 31st December 2035 it will stop doing the post-closure period, because If it is still produces leachate, if you're still seeing some of the gas being produced, you will have to continue monitor that. So you have to look at the leachate quality, gas, and all those stuff. Then before you finally say, yes, I don't want to do this post-closure care any further. And then you can use that site for some redevelopment. So during the period the landfill is in operational, we have to accrue some money so that the money can be used for closure and post-closure. Because it requires a lot of, if you have to manage, if you have to even keep an eye on that landfill for 20 years and do the groundwater sampling, do the leachate sampling, look at the gas. So it costs money. You have to get a consulting company or whatever. So so you have to have enough money. So that money will come from the tipping fee, the fee that a landfill will charge to the waste generators. So the waste, whoever is bringing the waste to the landfill, there is a money associated with that. For example, something around 1,500 rupees per ton or 1,400 rupees per ton. That also depends from place to place, how much is the cost associated with that. So as per Solid Waste Management Rule 2016, there is a requirement for closures are outlined. You need to have a final cover design. You need to have closure plan. You need to have post-closure plan. And we'll talk a little bit about that. It says that once you have when the landfill reaches full capacity, you're not accepting additional waste, you can it should be closed, and you can reduce the waste by biomining. If you don't see any further gas being produced, no more settlement. So you have to major settlement for like every 6 months or every year, and then you look at the leachate quality, gas quality, and if you don't see any of those, you kind of convinced that the waste is already degraded. So you can go for biomining, you can go for processing of the waste, and you can find the place for placement of the CGO in the new landfill, or you can do the capping. Capping is basically you put an enhanced geomembrane, and you can, if you need it, you can collect and flare the gas. So it's an additional measure. So you can put some extraction wells for pumping and other stuff. There could be any other method suitable as well, which you can make. So in a summary, landfill closure, the goal is to minimize maintenance. So we want to make it closure in such a way so that the maintenance is easy. Control erosion. We don't want things to be the waste getting eroded out or the cover soil getting eroded out. We have to control and manage leachate, control and manage landfill gas, manage the settlement. We don't want one area of the landfill. That's what we do during the landfill operation as well. We try to spread the garbage, different types of garbage in different parts of the landfill, so that we don't have a huge settlement in one area of the landfill and not much in the other area, because that will lead to some of the liner stability problems. And then, of course, we have to monitor the regulatory standard. So this is a typical landfill cap. This is how it looks like. You will have a solid waste at the bottom, then this is your gas collection pipe. You have some gas venting layer in between. Then you put a low permeability soil because you don't want the gas to escape through. You want the gas to pass through these pipes. And then you put some barrier layer, which is just to keep things safe from some activities on the top of the landfill, because when you have all these vegetative layer or you do different kind of activities on top, you have lots of vehicles coming on top of the landfill. So you put a barrier layer which actually pushing to all these systems below here to keep them safe. And then gas collector can go for gas recovery system and all that. So you have a barrier soil layer around 60 centimeters, you have a drainage layer of 15 centimeters, and then on top of that you put a vegetative layer. So you put some trees on top of the landfill, and that keeps the soil intact. That also helps in keeping the erosion low. So that's how a typical landfill. So if you go to a typical landfill, kind of from a distance, it just looks like any. You may get confused with a golf course as well, because with all that slopes and other things that is there. If it's done properly, you should not smell that much on top of the landfill as well. If you're smelling gas, that means there is some problem with the gas recovery system. So another picture of the same thing, you have the waste and gas venting, low permeable soil, then you do have a geomembrane here and the drainage layer, then you have a biotic barrier layer, so you put some wood chips and other stuff, you put a filter, so even if some gas does escape, it kind of gets it gets treated before it goes to the top layer. So on top you have the vegetation and soil top layer, and you put some vegetation on top. So this is how the landfill flow caps look like. When I say cap, it is on the top of the landfill and also on the side slopes. So this will be on the top as well as on the side slopes. That is how the caps look like. So in the final cover system, we try to have, we put a buffer to the waste, as you saw, several layers on top of the waste. We make sure that the gas is collected properly, and there is a barrier. There is some natural and artificial barrier, drainage, cover soil, topsoil, vegetation, all those things are part of that. And so once you have this, there are other systems which need to support this cap system, and those are we have to make sure that the storm water after the rain event, the storm water does not make a huge ponding on top of the landfill, because that will be a problem. So there has to be a proper stormwater control with proper slope. So that's stormwater occurring on landfill property or from area adjacent. They should be prevented from getting into the waste, because if it gets into the waste, although it should not, because we have the top liner on top cover with the LGP geomembrane, so it should not get in. But just in case, so if you did not have this, because what happens is you have the top liner and you have the side liner, and they need to meet at the anchor trench. And sometimes when the meeting point does not happen very nicely, because of the two is constructed at a way different period of time. So there may be areas where there is a chance of the stormwater getting into the landfill. So we have to prevent that. So we should not be let them get into the landfill, because that will create problem in terms of the landfill stability as well as for the leachate collection system, because there will be a lot of leachate being produced. So that we have seen in some landfill that is being happening. So stormwater system shall be operated that has to meet the requirement. So for example, this is one example here, the stormwater control. So we have stormwater channels. So as soon as we have to provide basically a nice slope and a nice drain. That's what it's all about. So in a simple way, you have to have nice slope. So any water coming on top of the landfill, they are on the side slopes of the landfill. We should take them away from the landfill as quickly as possible, and then put them into these stormwater channels so that they are taken away from the landfill surface, and so that it doesn't pond on top of the landfill. So you see the system is designed to route the stormwater away from the cover system, so it flows nicely away and with a nice slope. So, and then this needs to be maintained. We cannot let all the grass grow up here, or a lot of dirt coming in, and the slope gets messed up. So those needs, and that has to be done over the period of time for post-closure care. So all, again, that's why money is important. So there is it's a long-term management, routine maintenance for as long as 30 years. Sometimes it may even go longer, especially if you are taking municipal solid waste, which has organic matter is still there. If you have just the inert material, some landfills may be allowed to close before 20 years, 30 years. But again, it depends on, you have to look at the leachate quality and the gas quality, then only you will make the final decision. So you have to maintain the final cover. If you have to collect leachate, you cannot just, collecting leachate means you have to treat it as well. You cannot just dump it anywhere. So leachate needs to be treated. Groundwater needs to be monitored, especially when you look at the landfill site. On both sides, on the upstream as well as the downstream, you need to install some groundwater monitoring well to make sure that the lead liner is not leaking, and things are not getting into our groundwater. And so those things have to be looked into. Then gas migration. Is the gas making into the groundwater? Because that is also a problematic. So if the gas goes to subsurface, gas, we have methane and CO2. So that means additional carbon load. Additional carbon load means it has the potential to alter the biogeochemistry of the subsurface. So when it alters the biogeochemistry of the subsurface, that will lead to the pollution not only from the landfill because of the landfill, but also because of, say, for example, if arsenic is present, for that matter, or in the subsurface soil. And as we know, iron is a very good absorption site for arsenic. Now, if we create a reducing condition, and then we have this carbon supply in terms of the landfill gas, or if the liner is breaking and the leachate is also coming in, now this carbon supply will require, carbon needs to be oxidized. For that, we need a reducing agent. So for the reducing agent, the first preference is given to oxygen, but when the oxygen is used up, because you have put a liner system on top now, so there is no exchange of oxygen happening, there is a impervious layer on top. So you may, after oxygen, you will have nitrate. If you remember from that biogeochemistry, if you have read about that, after oxygen, the next preferred electron acceptor is nitrate. Then you have iron and manganese. Now, if iron acts as the electron acceptor, what will happen? Iron will get reduced. So reduced iron means dissolved iron. Iron 3, which is a typical form of iron in the environment, it's a stable form, it's a solid form. But when it goes to iron 2, it can dissolve. Now, iron got dissolved, so what happened to arsenic? Arsenic lost its home because arsenic was on iron surface. Now, iron got dissolved, so arsenic will come into the groundwater. So although arsenic is not coming from, arsenic is there in the soil, as we see in many parts in India or Bangladesh and a lot of countries around the world, we have this arsenic problem. Arsenic is there in the subsurface. It's a naturally occurring arsenic. We are not supplying arsenic to that. It's not the leachate which is supplying the arsenic. It is just because that biogeochemistry of the subsurface got altered, that is leading to, because arsenic lost its home. Its home was iron oxide surface. That was the absorption site. Now arsenic will get into the ground. Next time it's rainwater percolates through that area because of there will be, of course, seepage, and the groundwater table will go high, and then at that time you will see arsenic getting into the groundwater and coming into the tube wells and all that. So that's not the cause of arsenic in Bangladesh, but similar things happen in Bangladesh too. Not because of landfill, but some other activities. If you are interested, we can talk about that later. But those are very, very important. That's why we need to do this long-term management. The leachate has to be collected. The leachate collection system needs to be maintained properly. There is always a chance of leachate collection system getting clogged, especially because of sulfur-based compounds. So that needs to be looked at very carefully. Leachate needs to be transported. It has to be treated. So these days, even you can have we have robots which can go into this leachate collection system pipes and help us do those cleanup. So if you go on YouTube, you may find some of those robot videos. Then gas has to be collected and maintained on site. Inspect the collection system. Condensate removed. Condensate is when the gas comes out. The gas, since the landfill is slightly warmer than the ambient, so we have when the gas comes out, it cools down, so we have some moisture that needs to be removed. Then if it's being flared, the flare has to be maintained, recovery system, record keeping has to be done. Landfill gas blower flare system, that requires regular maintenance, especially if you have sulfur-based and other gases. That is nasty for these equipments, so they require regular maintenance. You have to keep up, you have to have a good upkeep. That's your flare station right there, and this is the blower that all the vacuum and other things being controlled from here. So, and it's of course has to be in a locked environment so that it doesn't get into some bad people's hand. So for all that requires money. So we need to have we need to estimate the cost to find out the money that would be required. We have to establish the fund for that. It could be at the form of trust fund, could be letter of credit, could be bond, some insurance, financial tests, guarantees, combination of mechanisms. So somehow we need to have money to do this for 30 some years. So you can do it from the example requirement. You do the cost estimate. You do also adjustment because of there will be always inflation, and so you need to have those key adjustment as well because you're looking at 25, 30 years time period. Landfill management. You need to have proof of financial assurance, cost estimate, adjustment of that. So those things needs to be done. And then you need to come up with different costs for leachate pumping, transportation, groundwater monitoring system, any other cost with compliance with rules. There may be some changes in rule later on, which you may have to still apply to, so you keep some buffer there. So those need to be done. The cost needs to be estimated and certified by professional engineers or a third party. That needs to be done as well. And then for maintenance, you need to take care of surface, record, we need to keep the record, do the monitoring. So usually these things are, what happens is, this is also done in many places as a part of PPP. So the municipality will hire a consulting firm, and then the consulting firm will do all this stuff and they give the report to the municipality, who will turn will submit it to SPCB and then to CPCB. So, but they will do it, and then initially it needs to be done every 3 months, then 6 months, then once a year, depending on if you have no problem. If you have problem, then the frequency changes. So, but then you have to do things for all this stuff. So in terms of the post-closure, you have to monitor the leachate, monitor groundwater. We talked about that, and monitor the landfill gas. And say again, some examples, the road, for example, the road needs to be maintained so that it's accessible. Drainage system needs to be maintained. You don't want this kind of stuff happening to the drainage system. The excite access must be controlled. We should have a closed gate system. Access needs to be controlled, and these things should not build up. So although it looks everything was working, but as if you hope you saw that actually the door is the lock is broken, and you see all these things being built up in there. So those things are not acceptable. And so after if you watch it for several years, what should you do? Should you watch forever? Should be converted to golf courses and parks. You can mine. All this, like both bullet 2 and 3 is being used, is being done. Some of this landfill has been converted to golf courses, some of has been converted to parks, and even the landfill mining is happening. Landfill mining is happening. Some places even they are doing a ski slope, a ball field, amphitheater, playground. For example, this Indraprastha Park was an old dump site. So those things are there. So once you have the landfill being closed and the waste has degraded for a period of time, you don't see much landfill gas being produced, you don't see much settlement, and you have to make sure you have to look at the health and environment. You can build some structures on top. You don't want to build too big because it's still you have the landfill. If you put too much pressure on top, it may have settled down because it's not the soil, it's the garbage in there. So if there is a chances of that, so you need to actually look at what is the geotechnical property of the landfill, like a decomposed garbage. So that leads to the landfill mining, which is a process where we can use we can excavate it once the garbage is already stabilized. No more further degradation of garbage. So it's mostly inert material. We can excavate it. Potentially, can use it for can use it for a construction material, or can be used as a cover soil for the landfill. Most of the landfill mining that is happening that has happened is happened on an old dump sites where the old dump sites were mined. Some of the materials were recovered because, again, some of those recyclables, which is recyclable, which can be recycled today, could not have been recycled earlier. And we can recover these ferrous and non-ferrous metals much better today than what it was, say, 20 to 30 or 30 years ago. So the technology has improved. So we are trying to use that. So it does help in conservation of landfill space, reduction in the landfill footprint, and you eliminate potential contamination source because the liner, even if it's a landfill liner after a certain decade, it will have a tendency to break. So if you take the waste out, many times what they do is they put since finding a new site for the landfill is very difficult, so they are what we try to do is we use the same like a landfill space, but we put a new liner system on it, and then go back and put the new garbage and use the garbage which came out of the old landfill as a daily cover material if needed. So you can rehabilitate. Energy recovery can be done from the recovered waste as well if it's a good calorific value. So essentially, and then a lot of project is being happening around the world, as you can see, even in India. Things are being working. US kind of leads the pack over there with 19 projects happening over there in recent decade. So in terms of, you have to look at the composition of the waste. What is the market value? Again, everything economics has to work. So what is the efficiency of the proposed resource recovery process, quality, likely environmental impact, logistics, where to do the processing, what will happen during the rain event. Say if you have, after rain event, you have things may become kind of leachate, how you do that, how you manage the noise, dust, order, traffic, what is the community's expectation. So all those things needs to be there. There are some examples, like in Barrie, Canada, they do that waste excavation, screening, and recompaction. They mine the landfill, they mine a fun line cell and place a new line cell. That's what I was saying. Perdido landfill, again, do the same thing. They put a line cell there. They reuse the landfill airspace. They upgraded the landfill with a newer regulation. And they also did waste to energy because there was, after doing some segregation of the garbage, after removing those soil kind of material with other material, they could use other material as a good calorific value source for waste to energy. And Taiwan is the largest planned landfill mining program. It's APA of Taiwan is planning to 404 landfills and use it for energy production. So that's what is going on. In Belgium, they're trying to do that too. Georgetown and Grand Cayman is planning to do something as well. So there is a lot of planned overseas project is there. In India also, people are talking about landfill mining, and we see some of the tenders are coming up for landfill mining as well. So in terms of existing environmental issues, we have the informal recycling, resource recovery, and the scavenging offers at landfill site. It's unsuitable for existing location in some countries because the landfill mining can recover valuable materials from the landfill, address landfill safety. We have to make sure. So these are some of the stuff. Say we are doing regular mining, we can get some of the recoverables from landfill, and then we can bring it back to our economic cycle. So that helps. That can be used. Landfill containing urban solid waste stocks. So another example, the landfill containing industrial process residuals, we can use that. We have a primary ore. This could be a secondary ore that can come back to the economics and can be used as a source of secondary material. And this is like you have existing landfill sites. This is in the around 150,000 to 500,000 landfills in the European Union. You can do, there are different options they were looking at. If they do nothing, or they could do classic remediation with re-landfill, if they have to make sanitary landfill. European Union, as you know, has been going very big on waste to energy. So they are looking at if they can take this material, produce RDF, and go for waste to energy. And then if needed, part of it could be used for sanitary landfill as well. And then looking at the use of raw bottom ash, fly ash, cement, and all that. So those, they can do some advanced mechanical processing as well, scenarios like new mine. Deonar landfill, which was dumped, then the mining was done in 1989. So that was, I think, one of the first landfill mining in India, at least. So in terms of summary, it can be used to recreate landfill airspace. Rigorous cost-benefit analysis is needed. We have to do some on-site trials to prove that landfill mining is economically viable. We have to look at the logistic and environmental management. There is a huge potential, especially in the developing countries. Especially, say, for example, we are working with Guwahati right now. Guwahati has a landfill site, and although NGT wants them to get another landfill site, it's very difficult to find a new landfill site. So if we can, the existing landfill is simply a dump site. So if we can convert that dump site into a good engineered landfill facility, and so that will at least reduce the concern that the NGT and other and then and the other people like us have in terms of that creating some problem for environment. So and if the calorific value is good there, which can be future energy demand can also come from there, especially plastics. If plastic can be mined and used as a waste to energy. So that's kind of pretty much bring it to the close of this webinar.
Thank you, Dr. Dubey, for this interaction, and to all the participants for tuning in. Please do join us for our next webinar on 17th November on ambient monitoring of methane and management of landfill fires and odor control. Thank you, Professor Dubey. Thank you all.
Thank you.